Alright, y'all, welcome to the second lesson of our unit on absolute value functions. Last class, we talked about how to solve equations with absolute values. Now we're going to talk about solving inequalities. So instead of an equal sign, there's the little alligator symbols. Don't worry, this is actually super easy. So first, let's talk about you get something that tells you the distance from x to 0. So as soon as you see distance from anything to 0, you should be thinking absolute value, because absolute value just tells you how far away from 0 something is. So absolute value of x. So the distance from x to 0 is less than a units. So this just says the absolute value of a mystery number is less than some other number. Okay, so what that's going to look like is here on a number line, if you got the absolute value of something, we learned last time that the value that's over here could be positive or negative, right? So I'm going to put a negative a over here and a positive a over here. And this is not inclusive, so they get open circles. And this could just be anything in between those two. So the value for x could be anything in there, because it has to be less than a, or it could be greater than negative a. And then over here, once again, distance from x to 0, so I'm immediately like absolute value is greater than a units. So now we got the other inequality sign. And it's going to be the same idea down here, where it could be positive or it could be negative, and it's also not inclusive. So open circles, but this time the inequality is going to go this way and this way. So x could be anything as long as it's not in between the two of these. And that's really all there is to it. Let's go try some practice. Let's put some numbers on this. All right, example 1. Absolute value of x minus 5 is less than 2. So if you remember from last time, the first step for solving an absolute value equation is isolate the absolute value, which right here it's already done for us. Great. And now the second step is split positive and negative. Now that is where inequalities are a little bit different. So we got x minus 5 is less than 2, but it's also going to be greater than negative 2. So instead of writing two separate equations, I'm just going to write this one compound inequality where I just take this value and put it here on the left and make sure the inequality symbols are facing the same direction. As long as you set it up like this, you'll be okay. And then from here, we solve it just like an equation. So I hit, right, I got to get rid of x minus 5. I need to put the 5 back. So plus 5. And I also got to do plus 5 over here. So we end up with negative 2 plus 5 is going to be 3. So 3 is less than x, and 2 plus 5 is 7. So x could be anything from 3 to 7. So I'm going to put 3 here, going to put 7 over here. This is not inclusive, so they get open circles. And x could be anything in between these. Doesn't this look just like inequality notation for domain and range? So x can be anything between 3 and 7. So let's try it again, this time with a less than or equal to sign. So we got 3x minus 4. We just dropped the inequality symbols. It's less than or equal to 8, but it's also going to be greater than or equal to negative 8. So we add 4 to both sides. Negative 8 plus 4 is negative 4. Less than or equal to 3x. Less than or equal to 8 plus 4 is 12. And now we divide everything by 3. So we divide. So just think of it as just like before when it was an equation, you did anything that happened on one side, you do to the other side. Now it's anything that happens in the middle, you do to both sides. So we're dividing by 3. We get negative 4/3 is less than or equal to x. Less than or equal to 12 divided by 3 is 4. And don't worry, I know that's a fraction. Fractions aren't scary. So we're going to put negative 4/3 over here. I'll put 4 over here. Now this time they're included, right? It can be equal. So they get a filled in circle. And x can be anything in here. All right, flip your paper over to the other side. Let's look at example 3. 2 times the absolute value of 10 minus x is greater than 7. So now we actually have to isolate the absolute value, don't we? So let's divide by 2. And we get absolute value of 10 minus 2x is greater than 7/2. Again, don't worry, it's just a fraction, it's okay. So now, let's write that as our split compound inequality. Negative 7/2. All right. And now, so this is weird, 10 minus 2x. I'm going to get rid of the 10 first, so we're going to subtract 10 from everything. And if you need help with subtracting 10 from the fractions, I'm going to switch to blue here and do that real quick. 7/2 minus, so we could think of this as 10/1, but we need that at the same denominator, so I'm actually going to do 20/2. 7 minus 20 is going to be negative 13/2. And then negative, so negative 7/2 minus 20/2. And I get negative 7 minus 20 is going to be negative 27/2. So going back down to my inequalities, it's going to be negative 27/2 is greater than negative 2x is greater than negative 13/2. And now you're probably thinking we got to divide by the negative 2x, and you're right. But weird stuff is going to happen, so I'm actually going to split those up. So divide by 2. So when I divide by 2 down here, what's actually going to happen is that it will multiply by these. So I got negative 27/4 is greater than negative x is greater than negative 13/4. And now I'm going to divide by the negative. And so what's going to happen here is we divide by the negative, so I have positive x and positive 27 over 4 and positive 13 over 4. But whenever you divide by a negative with inequalities, the inequality symbol flips as well. So the inequality symbols are actually going to face the other way now. It's very important, don't forget that. And so now we got x is going to be greater than, right? Yeah, x is going to be greater than 27 over 4 and less than 13 over 4. So we'll put 13 over 4 down here and put 27 over 4 over here. This is not inclusive, so open circles. So if x is greater than 27 over 4, it's going to go this way because it's greater. And it's less than 13 over 4, so it's going to go this way. And x can't be anything in the middle. All right, let's do one more. Oh, look, this one's actually going to be even easier. There is nothing outside the absolute value, no negative. So we just do 5x plus 10 greater than 15, which means we also have to do less than negative 15. All right. Standard procedure, let's take away the 10. That gets us negative 25. We still have the 5x in the middle, and 15 minus 10 is going to be 5. Then we divide everything by 5. Negative 25 becomes negative 5. X greater than 1. So now, let's see, I'll put negative 5 over here. I'll put 1 over here. Open circles because not inclusive. And x is less than negative 5, but greater than negative 1, or greater than positive 1, sorry. Now let's take a look at one more. X absolute value of x minus 8 is less than negative 2. So let's set this up. X minus 8 less than negative 2, and then greater than positive 2. But that doesn't seem like it makes very much sense. Let's try working it out, see what happens. Boop, boop. So x has to be greater than 10. Whoops. X is greater than 10 and less than 6. But this is weird. Can't be this. Because that's an absolute value, right? And remind me, what does an absolute value do? It makes things positive, right? So is it possible for an absolute value to be less than a negative? No, it can't be, because it has to be positive. So this is bad. Doesn't actually work. That won't work. In fact, if you tried to check for extraneous solutions, if I put in 10 over here, it'd be 10 minus 8 is 2, and positive 2 does not equal negative 2, and I can put in 6 and do 6 minus 8 is negative 2, but you take the absolute value, it's positive 2. Again, positive 2 does not equal negative 2. And then, so for our graph, we're going to call this empty set. You can put 6 and 10 down here if you want, but this is an empty set. X can't be anywhere on here. This is not a real thing. All right.